Alright, what's going on? It's me again, that guy, Oliver. Go ahead of programming. We're doing another programming tutorial. I hope you guys enjoyed the last one. Saw some good questions in the Google Classroom. Ask questions in the Google Classroom if you're confused. And as always, let's go! Alright, so as you can see, I have pulled up Replit here. And I guess let's just jump straight into it. So one thing that I want to cover from the previous lesson was what we call Boolean Algebra. If you're taking geometry right now, if you're a freshman, or if you're a sophomore or whatever, if you're taking geometry, you probably have done or are doing logic. It's similar to that. You know, you have ands, ors, nots. So let's get into that. So I'm going to start with declaring an integer, x. Let's give it a value of 5. Let's give an value of, actually, let's break away from the standard x and y convention. Let's say coolness. All right, and poolness. Yeah, 10. So let's say we want to see if coolness is greater than 5. Let's say, or greater than 4. This would run out that print line. Get a value. Oh yeah. Also, one thing I want to mention: a string. I forgot to mention in this previous one. A string is enclosed by quotes, like a dialogue. You use some quotes to enclose a string. So if I were to make a string up here. Also, notice how string is capitalized. Saw the Google Classroom question. String is capitalized. That's because it's not exactly like an integer or a double, but we'll get into that later. So let's say string. Wow, I'm struggling to come up with the names now. String cyborgs equals the team 1155, right? Our team number. You can see that we use quotes to enclose team 1155 to denote that it's a string. Alright, so let's say we're going to print cyborgs. We should expect coolness is greater than 4. So we would expect this to give us an output of team 1155, the cyborgs variable. And you can see here we don't use quotes because we're referencing the name of the variable and not actually trying to create a string with cyborgs in it. So you see if I put quotes here, it would print out the string cyborgs instead of the value that's actually in the variable called cyborgs. Alright, so let's say we also want to check, we only want to print out cyborgs if coolness is greater than 4 and poolness is greater than let's say 6. So we could do something like this, right? Well, if coolness is greater than 4, well, if poolness is greater than 6, so then we know if both of those are true, then we can print out cyborgs. Right? And this is going to do what we want. Coolness is greater than 4, poolness is greater than 6, so it should print out cyborgs. Alright, team 1155, exactly the value stored in cyborgs. If we raise poolness less than 6, you can see it doesn't run because poolness isn't greater than 6. And then if we raise coolness to something that's not greater than 4, for example 4, not greater than 4, you can see that's also not going to run. So we only print this out if both coolness is greater than 4 or poolness is and poolness is greater than 6. So how do we combine? Like if we, let's say we had a lot of conditions. We also had I don't know. Stick with this ruleness. is greater than 7, you know, then then only then do we want to print out cyborgs. You can see we can start nesting a lot of if statements. Obviously, this is going to throw an error because we don't have realness defined. But we can nest a lot of if statements to make sure that all of these are true. But this, like how we mentioned with nesting if statements, if-else statements in the previous video, this can get hard to read. So, what we can do to avoid that, all this mess, is instead we can combine the poolness is greater than 4 and the coolness is greater than 4 and the poolness is greater than 6 checks into one statement. And the way we do that is with 2 ampersands. It's if you press shift and then your 7 key, you'll get that. So what this 2 ampersands mean is and, like from your logic class. Basically it checks if coolness is greater than 4 and poolness is greater than 6. I think I got rid of a close bracket by accident. Then we want to print cyborgs. Alright. Sorry. Oh. Alright, so this kind of funnels into my next topic. What to do if you get an error. So you can see it in the console log here. This is not team 1155. None of that is in here. Right? So let's see. What do we get? How do we decipher what's going on in here? Because this gives us a lot of error. Exit status 1 and 1 error location. So what's the most important thing? I would say the most important thing in here is looking at this. Main.java, that tells us the file we're in, right? And then 7. So that tells us on line 7, there's something wrong. We can see this is underlined in red. Well, let's say it wasn't like that. We can see, this is error cannot find symbol. Basically means what variable is this talking about. You can see the little caret is pointing to this cyborgs variable. So something's wrong with this cyborgs variable. You can see I spelled cyborgs wrong. I put RO instead of OR. And you can see if we run this again, it should work. Yes, but coolness is not greater than greater than 4. So now it should print out cyborgs, the value stored in cyborgs. There you go. So great. So now we have a check if coolness is greater than 4 and poolness is greater than 6, then it runs and prints out cyborgs. Otherwise, it doesn't. Right? All right. Cool. But let's say we want to do an OR. That would be something like we had 2 if statements in a row that do the same thing. So let's say we said if coolness is greater than 4 and if poolness is greater than 6, system.out.println cyborgs. So we can see, well, if coolness is greater than 4, it prints out this, and if poolness is greater than 6, it prints out this. Yes. And see if we run it. This is going to give us if coolness is greater than 4, then it prints it out, which it is in this case. And if poolness is greater than 6, see it also prints out cyborgs. So let's say we wanted to combine these 2 if statements into one. Technically, this isn't exactly correct because if I were to set these both, it would print out twice. But let's say I just wanted to check each of these individually, and if either one is true, if coolness is greater than 4, or if coolness is greater than 6, then we want to print out cyborgs. The way we do that is with 2 vertical bars. If it should be above like your enter key, above the backslash, and if you press shift and then backslash, you'll get this vertical bar, and 2 of these denotes OR. And say if coolness is greater than 4, or if poolness is greater than 6, then it runs. You can see if both of them are true at once, at least one of those needs to be true. At least coolness is greater than 4 or poolness is greater than 6. At least one of those has to be true. Alright, so that's or, and in order to the main ones, I mentioned earlier, you can use an exclamation point to denote not. So let's say we want to check, this would be not the best example, if we want to say coolness is greater than 4, but if coolness is not greater than 6, right? So we could really say if coolness is less than or equal to 6. But for this example, let's just say I want to make sure it's not greater than 6. Let's see. Coolness is greater than 4, so it ran. Let's say we switch this to an AND. You should be able to see why it should not run, because coolness is greater than 6. This inverts it. Coolness is greater than 6 is true. If we invert that with the exclamation point, we get false. You can see true and false gives us false, and it doesn't print anything else. Alright, so that's Boolean algebra. That's kind of what we call, using ands or ors and inverts, exclamation points in our code to determine function. Yeah. So let's say I want to do something a bunch of times. Let's say I want to print out cyborgs a bunch of times, just because I love the cyborgs. I love my team. It's so good. I love my team. The print line cyborgs, right? Let's say I want to do this a bunch of times. Well, how would you do that? Oh, I can just copy paste the code a bunch of times, right? Look, it's going to print out team 1155 a bunch of times, right? That's what I want. Nothing's wrong about this, right? Those that already know coding are probably screaming their heads off. Not very good. Generally, repeating code like this is not something we want to do when we're programming, because there's a way to condense these, and that's using loops, which is what we're going to talk about now. Alright, so the first loop that I'm going to kind of introduce is called the while loop. What the while loop does is that, you know how like an if statement, it runs something once if the condition is true. So let's say poolness is greater than 2. System.out the print line cyborgs. So you know how if an if statement, if something is true, then it runs this block of code once, right? Using the curly brackets. Let's inside the curly brackets. If this is true, it runs it once. What this does is, once it gets to the end of this code block, it goes back and checks, okay, is this condition still true? And if it's still true, then it's going to run it again. And it's going to keep on running it until it becomes false. So this can actually, if I try to run this code right now, you can see it keeps on printing team 1155 in the console, because we see, okay, system.out.println cyborgs, and it goes back. Poolness is still greater than 2, and it goes back. And it prints it, and then it goes back. Poolness is still greater than 2. Goes back, prints it, and goes back. Poolness is still greater than 2. So it's gonna print to this console forever, really. Nothing's gonna stop it. Hit the big red stop button at the top. It's gonna stop it, but nothing is stopping this loop in the code. So this is when using while loops, it's very important to not make sure you're not getting stuck in an infinite loop. Sometimes it even happens in our code where it gets stuck in infinite loops and the robot stalls out or something. We really don't want that to happen, especially during a competition or something. So how do we avoid this? Well, you see, poolness is greater than 2. Let's say I then subtract 1 from poolness. You can see I'm reassigning the value of poolness to poolness minus 1. I've said poolness so many times it's not seeming like a word anymore. So, and the reason we can't just do poolness minus 1, say something like this is just a value, right? Poolness minus 1 Like that's just going to give us 6 as a value. And what does 6 mean? It doesn't mean anything. So what we need to do is then have poolness be assigned to poolness minus 1. And that way, poolness will actually be updated with the value of poolness. And there is a shorthand of doing this. Instead of doing poolness equals poolness minus 1, we can just do minus equals. So when we put a comment, use 2 slashes to make a comment, by the way. This is equivalent to poolness equals poolness minus 1. You can see, now when we run the code, I'm going to bring poolness down slightly lower so I don't have to repeat myself so many times. You can see, so now let's think about what's going through the code. It checks poolness is greater than 2. Yeah, it is. So it prints it out and increases poolness minus 1. It decreases it by 1. And then, okay, so now poolness is 4. It goes back. Poolness is greater than 2. That's true. 4 is greater than 2. So it prints it out again, decreases it to 3. 3 is greater than 2, so it prints it out again, decreases it to 2. 2 is not greater than 2, so it stops and it reaches the end of the code, and our code is over. No infinite loop. That's good. So let's see. Again, this is when poolness was 5. This is when poolness was 4. And this is when poolness was 3. And you can see, actually, I can print out poolness here. You can see that for yourself. You can see it prints out 5, 4, 3. Because once this is 3, it goes. It decreases it to 2, and then it goes back. 2 is not greater than 2. So you can see if I do 10 up here. It goes from 10 down to 3 and then stops. So this kind of repeating pattern is very helpful. While this is true, just keep on running. And you can see repeating something a certain number of times, or until something is true, is like very helpful. So let's say we want to check, well, this is greater than 0. That's going to give us a slightly more intuitive result. And see, it's going to go from 10 down to 1. So great, we just repeated a piece of code. We can now print out cyborgs exactly 10 times, right? Print out 10 times. We can change this and we can say 20, and you can print it out 20 times. You know, and it should be obvious why that's better than trying to copy and paste system.out.print lines. A bunch of them, and 1, 2, 3, 4, 5, 6, 7. You can see why this is much better. We can change it on the fly. We don't have to, okay, well, maybe if I want this many or this many, oh wait, I want to go back. You know, a while loop is much better. And so repeating something a certain amount of times is very helpful. So we actually have a certain syntax for doing that. For condensing this int poolness equals 20, poolness is greater than 0, poolness minus equals 1. We actually have a way of condensing all of that. And that's called the for loop. So what does a for loop do? There are 3 parts to a for loop. I guess 4 if you count the code block. So in this first one, we're going to make usually an integer. This is the assignment part. We say int I equals 0. Usually I is used. It's just kind of convention. It's the one you use when you're in a for loop. And then we have our conditional up here. So if this first part is equivalent to int poolness equals 20, the second part is equivalent to this conditional inside of the while loop parentheses. We can say I is less than 20. And then we want to copy this kind of part in our for loop as well. So you say I plus equals 1. This is basically the same. It's just doing it in reverse. Instead of going from 20 to 1, this is going to go from 0 to 19. you can see it's gonna run the code. Let's say system.out.println I. Alright, gonna get rid of this for now. Actually, I'm actually gonna comment this out. My computer would respond to me. There we go. And the way you comment a bunch of stuff out is using these forward slash asterisks and then asterisks forward slash. This comments everything in between those out. So none of this code is gonna run. None of the code in any comments is gonna run. Right. Okay. So for into I equals 20, into I equals 0, I is less than 20, I plus equals 1 is gonna print I. So let's think about what this is gonna do. It's gonna assign it to 0. It's gonna check. Okay. Yeah, 0 is less than 20, and it's gonna print 0, and it's gonna increment it by 1. And it's gonna go back, and it's gonna see, oh, okay, I is now 1. 1 is less than 20. All right, prints it out, and then increases I again, and it's gonna keep on doing that until it reaches 20, and it's gonna say, wait, 20 is not less than 20. Stop. So it leaves this for loop and stops at 19. Right. So going over something a certain amount of times, very helpful. That's why we have a for loop. And something that goes often hand in hand with for loops is something called an array. So what's an array? An array is basically a collection of values. So let's say you guys all took a test. You guys all had some homework, right? And we say, well, student 1's grade on it, let's say int student 1 equals, they got a 90. Pretty good. Int student 2, they got 100. They were great. Int student 3, they got 110. They went above and beyond. They broke pupil path. Student 3. So let's say and let's say we want to print all their scores. Okay, we could say system.out.println student 1. And system.out.println student 2. System.out.println student 3. I typed student net again. Student 3. So we could do this, and we'd say, oh, we would print out all the values. Actually, I'm going to comment this out too, just so we don't get our code mixed up. We want to print out all the student grades. You can see we got 19, 100, 110. And let's say we had a class of 100 students. You know, we had a lot of people trying out this year. Not 100, but let's say we had a lot of students. It might be more how we wouldn't want to create a int student 4 equals 60. They did terribly. Int student. This is gonna get really old really quickly. So how do we put all of these together in an array? An array of values is basically a collection of values. So what we use to make an array in Java, so what we want to do is basically create a list of values, 90, 100, 110, 60, and so on and so forth, with our student grade values. So how do we do that in Java? Well, we first say what type of value we want to store in an array. In this case, it's integers. And then we use something, we use square brackets. And, yeah, it's just kind of the notation that we use. And we give it a name. Let's call this students. And then, let's just keep it there for now. We can say, oh, we have an integer array called students. Now, how do we give this a value? So we want to create this array of students, right? So how do we do that? Well, we say we have an integer array, students. We say that's a new, using the keyword new, integer array, right? Oh, wow, this It's a new integer array. How helpful. We must also give it a length. The thing about arrays, they need a specified length. So let's say in this example we have 4 students. We're going to create a new integer array of length 4. This value inside of the square brackets means it's length 4. So how do we assign values to it? Well, we take the variable name, students, and then again we use square brackets. And we say students index 1, let's say, is 90. Actually, I'm going to change this to index 0. So why am I putting in here? This is setting the first value in students to 90. You're like, what? This is a 0. This is actually, by the way, this isn't length or anything. This is to get the index. This is called indexing an array. You can see basically every value in our array is going to have an index. The first one is going to have an index of 0. Second one is going to have an index of 1. The third one is going to have an index of 2. And the fourth one is going to have an index of 3. And because it starts counting at 0, we call like the arrays in Java are 0 based. Start counting at 0. And the reason is this: it makes some of our coding a little bit easier to make, and kind of just aligns with how it's made in memory, how it's represented in memory a lot more. So let's say we want to set the first, we want to index students, get the first value, and we want to set it equal to 90, just as if we were setting student 1 equal to 90 up here, right? And let's say we want to set the second value in the students array to what value? 100. And we want to print the third the third value in the students array. We want to index it at 2. Should have chosen an easier word to spell, apparently. And set it to 110. And we want to get this, and we want to get the fourth value and set it to 60. Dude, I really cannot spell students, huh? Great. Well, this doesn't seem too much better than our code up here, right? Well, we're basically assigning all the values. It looks a little bit nicer, right? It's all in this collection, in this collection of values, in this array of values. Like, this doesn't seem much better than we have up here. So if we want to initialize an array like this, set every value to something, what we can do, instead use this notation, which is we say new integer array, and then we use curly brackets here, and we separate what values we want in that array by commas. So let's say we want 90, 100, 110, and 60. Right? This should work, I believe. Okay, so it's giving me an error. If we give it a length and we also initialize it like this, it gets a little bit angry. It's like it doesn't know if this is going to be the exact same length as this. So what we do is we just leave the value out, and it's given. We can count here. Oh, it's an array of length. Where the computer can also count. It's very good at that. You can see this is much faster than writing student 1 equals 90, student 2 equals 100, student blah blah blah. And what do we do down here? Well, we just change it to students 0, students 1, students 2, index at 2. Then we want to get that fourth value, so we index it at 3. I can move my cursor around. And see, this should give us the same code, the same output that we had before. I guess with the 60 now in the example. 90, 100, 110, 60. You can see this is also taking up a bunch of space. We don't want to write this for every student either. If we have 100 students, that's also going to get pretty annoying. So, how do we condense this? Well, we use our friend that we just learned up here, the for loop. This is what I was talking about when I said that the for loops and arrays often go hand in hand. And see, this value, it went through values 0 to 19 for I. Well, here we just want 0 to 3 and to go through every value in the array. And we can say for int I equals 0. I is less than 4, right? Because we don't want 4 or greater. if we give it a value past 4, it's going to throw us, or past 3, it's going to give us an index out of bounds error, basically saying you're trying to get the 5th value in here, and that doesn't exist. So you get an index out of bounds error if you try to do that. And so we write a for loop. This should go through the values of 0 to 3. A and C, students, index, I, students. Should just start calling all my variables students if I'm going to type it like that so often, right? If we get rid of our code down here. And see, well, it's going to go through I equals 0, it's going to get the first value. I equals 1, it's going to get the second value. I equals 2, it's going to get the third value. I equals 3, it's going to get the fourth value. You can see it prints out all the values in student. And this is what makes arrays and a for loop so powerful, especially when together. Because then we can just add here 50, 60, I'm giving people low grades, 90, 100, 110, whatever. And we can see this is 4 plus 5, that's 11, I can count. 9, I can count. 9 values. So this is going to go through 0 through 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. And you can see it's going to print out all the values. And it's much faster than trying to write student variable, student 1, student 2. So let's say I have multiple classes. Well, should I create maybe, and I want an array for each of my classes, let's say. So should I create a new integer array for every one of my classes? Let's say I have, oh, sorry, I clicked the wrong button. It's going to give me an error. Should I create new students array for every class, and then students, let's just do students 1 here, and then, well, I have a bunch of classes, right? So I should just have a bunch of for loops in here. Go through all my student classes. Students 3, students 1, students 2, students 3, students 4. And you can see this is kind of running into the same problem why we introduced arrays in the first place, right? To prevent this kind of copy-pasting code. So what can we do? We kind of want an array of arrays, right? If each class is an array, then we want an array of all our classes, aka an array of arrays. So the way we do that is with a notation, I guess, that looks like this. We say that an array of an arrays, we use 2 square brackets to note it's an array of arrays. We can say it's a new integer array of arrays, and then we have to change all of these values to be arrays in and of themselves. So we can use a similar initialization, just pretending that each, not pretending, but each of the values in this array also have to be arrays. So we can say, let's say we have only 2 students per class, 80, 90, 60, 70. You can see we now have a array of arrays of students. So the first value in this students, or actually, let me call this classes now. And this classes int array of arrays. And what we call an array of arrays is also a 2D array, because you got 2 dimensions. Imagine on like a grid or something, you had 2 dimensions. And say, well, the first value in this class's 2D array is the array of 190 and the second value at index 1 is going to be 80 comma 90, another integer array. Third value is also going to be an integer array. Yeah. And I guess these don't actually need to be all the same size. And this can be 10. We got a really bad student in this class. They don't actually all need to be the same size, but usually they are all the same size because that's a lot easier to work with. and especially when you're dealing with other representations. So, and we can run through this in a similar way. For int I equals 0, I is less than, let's see how many values are in this upper array. Well, there's 3, right? So then we want to loop through this like upper or outer array for 3 values, right? 100, 90 is the first one, 80, 90 is the second, 60, 70 is the third. And then we want to do a nested for loop. And we want to say j is usually what we use after I. We want to say, well, there are 2 values in each array down here, right? There's 190 in this one. 100 is the first, 90 is the second, and then here 80 is the first, 90 is the second, and so on. And we want to keep on adding to this I plus equals 1. Sorry, j plus equals 1. Sorry, a little bit of a logic error. And then what we do to index a 2D array is we say, okay, well, what outer array do we want? Here we want I, right? 0, 1, or 2. And then what inner array do we want? And you can say we want index j, you know, it's either 0 or 1. So let's say we got 0, 0, that's going to get us the first value in the first array. 0, 1, that's going to get us the second value in the first array. 1, 1, 0, you're going to get the first value in the second array, and so on. So let's say we have our variable, or our value, and we want to print it. And see that we should get all of our student grades. Yes, okay. Replit was just being weird for a second. Great. So now we have a 2D array. And let's say printing out all the values in the array is something we want to do quite often. And you know what, guys? I'm actually gonna call it there. I think, you know, we've talked about a lot today. We've talked about, first we started off with Boolean Algebra. We want, you know, if you get an error, how do you decipher what's going on in the console over here? I wish Replit would not be like this. And we talked about while loops, which continue over and over until this condition is false. Then we talked about for loops, which are really good at doing something a certain number of times. Then we went over what arrays are and why they're useful, and then 2-dimensional arrays, and how to use arrays and 2-dimensional arrays with for loops. And I think I'm gonna leave it there for now. I hope you guys enjoyed. I realize these videos are getting a little bit long. I'll put this in the Google Classroom too, but feel free to skip around to play it at double speed. I mean, that's what I do to YouTube videos, and sometimes my teacher videos are ed puzzles too. So like, don't feel bad at all for doing that, because a lot of this I realize I'm a little bit rambly. But I hope you guys enjoyed. I hope you guys learned something, and that's gonna be it. All right, thank you guys. Bye.